So specific to your inductor capacitor and your inductor capacitor resistor or the combination, we have the power in an AC circuit with different set of expressions. So controlling that is something called as power factor. So this is the expression that will help us or determine what's going to happen. So let's recall power expression. So this is ERMS or E naught I naught by 2 cos phi. So this is fixed, you know. So what changes in your combination is phi. Once you change the LCR combination, phi will change. So this is your variable. And that is given the name power factor. So it's called as aka power factor. Okay guys, so the definition is that we have I naught E naught by 2 cos phi. So from the equation, we can derive the average power dissipated depends not only on the voltage and current, so for fixed voltage and current, but also the cosine of the phase angle phi between them. The quantity cos phi is called the power factor. That's your definition. Now, let's look at the math. Just a second. I wanted this. So you remember we are VL minus VC, right? And say this is basically your R, right? And this is nothing but your XL minus XC and all of that. Okay, I hope you guys remember this. And all of this derivation, what do you end up with? You end up with cos of phi. That will be equal to R by Z. That's your Z. Adjacent by hypotenuse. So what is Z? Where Z is? Where Z is equal to your R square plus omega L minus 1 by omega C, the whole square. Okay, let me, no space. Z square is equal to that. Again, you guys can write root over there, not an issue. So what can we tell from this? When we talk about purely resistive, right? Let's pick up the specific scenario. Further, we can't do anything over here, but we can do with specific scenarios. When we have purely resistive circuit, what happens? Think about it. Yes, your phi will be 0. Is it not? So cos phi will be 1, and this is your maximum possible value. The maximum possible value. So this is nothing but your circuit is in resonance. So you'll get the maximum possible power. Is it not? So your P will be maximum and it will be equal to IRMS into ERMS. Does it make sense? Next, when we have purely resistive or capacitive, what happens? What happens with your phase difference? It will be 90 degree. So cos phi will be 0. Is it not? Then what happens? Power will be equal to 0. Actually, this is given a special name. Let me, just a second. This we need to know. This is known as this scenario. In this scenario, we have the current called wattless current. Here, there is no power dissipated even though you have current flowing through, right? Even though a current flow or is flowing, current is flowing in the circuit. Okay, guys, this you need to know. This is there. Next, a series LCR circuit. So here we know that phi will not be equal to 0. And so we have power which is equal to IRMS, ERMS into cos phi. That will continue to be so. You guys agree? Next, and your phi will be equal to, actually we need to write this expression, tan inverse of XL minus XC divided by R. The inverse is to be taken for the entire expression. Okay, yes. And specific to that, at resonance, what happens? XL and or basically phi will be equal to 0, that we already seen. XL will be equal to XC. So when we resonate this, XL will be equal to XC. So phi will be equal to 0. So the power is going to be maximum. Yeah. So we happen to understand what is resonance. Resonance is a phenomena wherein we have the best possible output for a given input. Now, we can tune something. That is, we can resonate a particular circuit. So when we do that, we happen to see that the conductor and conductance and impedance, they work together and they pretty much cancel each other out, the effect, right? And we got to see that the object or the thing will resonate, the device will resonate at a particular frequency given by 1 by 2 pi root of LC and all of that. That is your resonating frequency and stuff. So when things are resonating, the power is maximum, you know. So we have to look at the expression of power in an AC circuit. And that turns out to be this particular expression. And for a given E and I naught and E naught, right? Your cos phi plays a role. And cos phi in turn is controlled by your LCR combination. And that's what we try to see. Actually, we are going a full circle. Does it make sense? So basically, we are going the entire circle and back to the same point again, actually. So I hope the math made sense. It just has simple substitution and recalling of things, nothing else.